if suppose we have 4 people, okay, or we have 4 students, you want to split them into 2 groups. One group with 1 member, one group with 3 members. How many ways are there?
4.
Exactly, 4. If you want to split them into 2 groups, each as 2 members, then it will be what?
Are the groups like distinct?
They don't have name.
So 3.
Exactly. 4 choose 2 over 2, right?
Yeah.
If we have 6 students and we want to split to 3 groups, each has 2 members, it will be what?
Is 6 choose 2 times 4 choose 2 over 3 factorial?
Exactly. Okay, so you know the idea. Now that you know this, if we split n squared students into n groups, each has n members. First one, second one to nth one. So, and let's try to write it only in terms of factorials. Okay, try to simplify at the end, and you can write it in terms of factorials only. Try it.
I don't know if I'm doing this right. I got like n squared factorial over n factorial to the n times n factorial.
N factorial to the n. Can say it again. It's what over what?
I'm kind of confused. Wait, n squared factorial divided by n factorial to the n times n factorial.
So it will be n factorial to the n plus 1, right?
Yeah.
Let me say, explain for you how you can calculate quickly.
And there needs to be another n factorial.
Let me calculate to make sure. Over n times 2 and choose n, and then n choose n, right?
Yeah.
All over what?
N factorial. There should be another n I think there's there's another n factorial in the
We can
exponential
check.
thing.
Let me check.
Okay.
I don't think, because look, for each of them, one n factorial, look, let me tell you another way. You say n squared factorial because of permutation of this one, so n factorial to the n. Because of the order, also n factorial. I think this one is correct. So let's see. N squared factorial, n squared minus n factorial, n squared minus n factorial, times n factorial, n squared minus 2n factorial, right? Times n squared minus 2n factorial, n factorial, n squared minus 3n factorial, 2n factorial, n factorial, n factorial, and n factorial, 0 factorial, okay? So you can see that we can cancel terms like these, second term, this one. So that in the numerator is n squared factorial, and the denominator we have n fractions, and also we have 1 over n factorial for the denominator of here, right?
Mm-hmm.
So now do you agree it will be n factorial to the n plus? N factorial. So it is n squared factorial or n factorial to the n plus, right?
Mm-hmm.
So we can conclude n factorial to the n plus 1 divides n squared factorial because we are calculating something, right? Number of ways to split. So this one is integer. So we can conclude this one divides this, right?
Yeah.
The key point of this problem, let me now copy the main problem. The problem is this, that this divides this. So try the rest.
34 D
E.
D 34.
Okay, let's check here. We can say n squared minus 1 factorial over n factorial to the n is equal to n squared factorial n factorial to the n plus 1 times what? N
Times n
factorial over n
squared, n
squared,
factorial
right?
over n squared.
Exactly. If this one is an integer, then the problem will be solved, right?
Yeah.
And then it is integer. So if we check for 1 it's good, right? For
Yeah.
2 it's
For
not
prime,
good. For
just the
3 not
primes.
good. Obviously for primes it's bad, right?
Yeah.
For 4 is good or not.
It's good.
24 over 16 it's
Oh yeah,
not
no.
good, right?
Oh yeah, it's not good. What?
5 prime not good. 6 it's good because you can write 6 as 6 and 2 3, right? So we can
Yeah.
have 2 6s. So 6 is good. 7 we know is bad. For 8 it's good. Why? Because we can write 2 4 8, right? And if n is a composite number, you can say n is this times n. If n is a, b, and a and b are. Let's if we can write it like this, right?
Hmm.
Agreed.
Yeah.
So in this case, it's good. So we can write which numbers in this form. So what numbers are left to check?
Angle A B. So like numbers like 3 times 4. No.
No, look,
Wait,
3
A and
times
B
4 is
prime.
12. You can write that 3, 4, 12.
Yeah.
These numbers are good. But there are some numbers that are left and we've not checked them yet. What
What do you mean
numbers?
n equals AB? What do you mean 3 times 4 times 12?
Look, for example, we
This is
want to see is it integer or not. For 8, look, 8 factorial over 8 squared, right?
yeah.
So when you write 8 factorial, it is 1, 2, 3, 4, 5, 6, 7, 8, right?
Yeah.
Over 8 squared. So look, 1 8 is the last one, this one.
Hmm.
Also, we can say 2 times 4 is 8.
Yeah.
So in this case, we have 2 8s and it is okay, it is integer, right?
Hmm.
Okay, I said if we can write n as AB, that A is strictly less than B, so you can say we can write AB n, and over n squared it will be integer, right?
Yeah.
Okay, so we proved prime numbers are not possible, and these composite numbers are possible that we can write them like that. So there are some numbers that we've not checked them yet. What numbers are left?
2, 10. 2.
10 is similar to this. Look, 10 is 2, 5, and 10, right?
So what do you what? The squares?
Squares, for example, look, 36 is 3 times 12, also 30. Not all the
Yeah.
squares.
So 49, the square of
Remember,
a prime.
prime squared. You cannot write prime squared like this, right?
Yeah.
So for prime squared, prove that this one is integer. Or for which prime squared it is integer. Check this one for n is p squared. We want to see n factorial over n squared is integer or not. Check it.
I mean, yeah, all of them work
Except p2, right?
except for P2.
So you should prove it. If p is at least 3, why this is integer? Try to prove it.
So you can write it as P squared factorial over P to the 4, and you can simplify that to P squared minus 1 factorial over P squared. So then you just need to prove that P squared minus P and P squared minus 2P are terms that are greater than 0. So P squared greater than 2P gives P greater than 2. So for P greater than 2, it works.
Exactly. Or you can say p 2p, right?
Yeah.
P squared. If you prove p and 2p are strictly less than p squared, the problem will be solved, right?
Yeah.
2p less than p squared is equivalent and p is greater than 2, right?
Yeah.
So for all numbers except for n primes, it will be good, right?
Mm-hmm.
So the numbers that are bad are what? 2, 3, 4, 5, 7, 9, 11, 13, 15, 17, 19, 23, 25, 29, 31, 35, 37, 39, 41, 43, 45, 47, 49 until all the way to 50. So 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 16. 15 minus 16, 34. Good.